Looking at scientific notation in numbers, scientific notation is just a nice way, a means of expressing values of vastly different sizes using a common presentation method. So we're talking about sometimes the distance from here to the sun. It's just so huge to put that with all the noughts, or maybe the tiniest distances in an atom, and they talk about they need to have the same scale for that. So they say, how do we do that in a common system? So what they use is they use a number, A, with the full the dot decimal point afterwards, B, C, D, whatever the numbers are, by 10 to the power of something. So what they do here is they look at the number here, 3,600, and they say, how would you express that in terms of the power? Well, they look at 3,600, and they say, how far away is that from this decimal point here? And they say, if we moved it one place, 2 places, 3 places to the left, we'd get 3 point something. To move something to the left, you're dividing. This is division. So what they say is, well, let's take this 3 by 3.6, and they say divide it by 1,000 to get 3.6, but multiply it by 1,000 as well, because you can't just make the numbers equal unless you're doing both division and multiplication. The 3.6 stays, and the 1,000 is 10 to the 3. 360, you can change that by dividing by 100, you get 3.6, and by multiplying by 100 to make up for it, you get that. 36 divided by 10 gives you 3.6, multiplied by 10, 10 is also called 10 to the power of 1. 3.6 is 3.6, or 10 to the power of 0 is actually anything to the power of 0 is just 1. 0.36, you don't like that. You prefer if the number was before the point, so you really have to move it here to the right. And to do that, you've got to multiply. So that's 3.6, but because I multiplied, I have to divide as well. So that's 3.6 divided by 10, or divided by 10 to the 1, or written as 3.6 by 10 to the minus 1. Here I have it twice. I'd have to move twice, multiply by 100 to get there, or divide and then divide by 100. That's 3.6 by 10 to the minus 2. So just 2 examples on that. And it says, convert the number 234 to scientific notation. What do you do? Well, you look at it and you say, I just want that to be a 2.34. Or 234 point, I'd have to move it twice. To move it twice, we're talking about 100. So I'm going to multiply by 100 and divide by 100. Why? Because I can't change the number, 234. So I'm going to both multiply and divide by the same number, 100. But that's the way I see it there, multiplying and dividing by 100. But if I'm clever about how I group it, and I use the divide here, and I use the multiply to the right, I get 234 over 100 by 100. The 234 becomes 2.34, and the 100 becomes 10 squared. So it's a question of how I use the 200s. Here's another example, similar approach. I've been asked to convert 0.0056 to scientific notation. Don't like it. I'd have to move it once, twice, 3 times to get 5 point something. 3 times means 1,000. So I'm going to multiply by 1,000 and divide by 1,000. So here I have the number, and I'm multiplying and dividing by 1,000. On the top, I'm multiplying. On the bottom, I'm dividing. But now if I'm clever about how I allocate which one, if I take the top one and use it for multiplying, I'll just get 5.6. And I'll use the other one then for the 10 to the 3. So 5.6 by 10 to the minus 3, and that's my answer there. And in this example, we're going the other way around. Here we're asked to say, convert the numbers 2.34 by 10 to the 3 and that from scientific notation. Well, 2.34 by 10 to the 3, 10 to the 3 is just 10 times 10 times 10, or 1,000, and we just simply multiply by 1,000. And to do that, we will do 1, 2, 3. So 2,300, that's a comma, 2,340. In this situation here, 1.45 by 10 to the minus 3, you're given this number. And you say, well, what do I do with this? 10 to the minus 3, well, it's 1 over 10 to the 3. So it's 1 over 10 by 1 over 10 by 1 over 10. So I have to divide by 1,000. Dividing by 1,000 means I take the number 145 and go back 3 times. 0.00145. And that's how we convert numbers in scientific notation.